your raw calculation, all of your raw calculation has to be done by hand. And that includes the following. How do we accurately approximate zeros and irrational numbers? For example, the square root of 5 to 4 decimal places. I could give you guys, I could say try to approximate to 4 decimal places. You might spend a good 10, 15, 20, 30 minutes in class doing a little guess and check method before you came up with something you thought was accurate, right? So here's what I'm going to do. We're going to show you how Newton did it. And he used calculus, and it is awesome. Newton said the square root of 5 is a solution to f of x equals x squared minus 5. And then he took it and he said that's where it crosses the x-axis. So we're going to model this with this example, and then we're going to write the raw formula that Newton used. So the function was f of x is equal to x squared minus 5. He knew that the square root of 5 rested between two integers. What two integers does it sit between? 2 and 3. And he said, I'm going to guess that the square root of 5 is 3. Now, of course, Newton would never do 3 because, he would know that that was way off. But let's just say he was a really bad guesser that day or he was being a little bit lazy. Okay? His initial guess of 3. If he takes 3 squared and minus 5, he wants to come up with 0. Eventually, his number, when he plugs it in, he wants to get 0, right? But when he takes 3 and squares it and subtracts 5, what does he get? He gets 4. And he realizes, whoa, I am way off. I'm way up here at 3, 4. That becomes a point on a line. This is where Newton laughs at us and says, watch how smart I am. Newton says, I know that 3 is a really bad guess, but I'm going to use that to come up with a super accurate guess. I'm going to write an equation for line tangent at that point. And when I write the equation for the line tangent, it's going to give me a new guess that is much more accurate. If that line is tangent to the curve f of x equals x squared minus 5, how would I find the slope of that line? What is the derivative of x squared minus 5? 2x. So what is the slope at 3, 4? Newton says I have a line. Y minus y1 is equal to m times x minus x1. Y minus what? 4 equals 6 times x minus 3. Newton says I'm trying to find what part of the line. What is the part of that line that's important for my guess to move forward? The x-intercept, right? The x-intercept happens when y is equal to 0. So if we set y equal to 0, we'll be solving for the x-intercept. So our equation becomes negative 4 is equal to 6 times x minus 3. I will divide by the 6. Negative 4 over 6 is equal to x minus 3. And then I add the 3, and I get 3 minus 4 over 6 is equal to x. So Newton learns that 3 was not a good guess, but 3 minus 4, 6, or 3 minus 2/3, or 7/3 is an excellent new guess. Now, as you look at the drawing, you may say 7/3 still looks like it's a little bit of a ways away. But watch what happens if he does his method again. He plugs it in, it gives him the point on the line, and then he draws the line tangent, and he looks for that x-intercept. Is that pretty close? He ends up getting really, really close. Let's do one more, and we'll do it by hand, okay? But let's do it after we actually generate the formula. It will be a little bit easier that way, okay? So the formula for Newton's method, it starts out with a function. The function being f of x. We then make an initial guess. We're going to call the initial guess x sub 0. Once we have the initial guess, we find the point on the line. The point on the line happens to be x sub 0 is the x value. How do you get the y value? We squared it and we subtracted 5, right? And so basically we plugged it into the function. So f of x sub 0 is going to be the y value for the point on the line. How did we find the slope? What did we do? We took the derivative and we plugged in our x sub 0 value. At that point, we decided to start to write an equation for a line. Y minus, what's our y1 value? F of x sub 0 equals, what is m? F prime of x sub 0 times x minus, and the x value is x sub 0. What happened to y over here? It went away. So it was 0 because we're finding the x-intercept. So we had negative f of x sub 0 is equal to f prime of x sub 0 times x minus x sub 0. It was this x value that we were solving for our new guess. That is the intercept that we're trying to find. So what do we do to solve for that? We divided both sides by? Yep. And finally, we add the x over. So x sub 0 minus f of x sub 0 divided by f prime of x sub 0 is equal to x, and I'll call it x sub 1 being our new guess. This is the formula for Newton's method. So I'm going to generate a rational expression, meaning a fraction that's very close to the square root of 5 by just doing it once again. This is going to be my new x sub 0. So I have 7 over 3 minus, this says f of x sub 0. So what do I do with 7/3? I plug it in. I take 7/3 and I square it, and then I minus 5, and I divide that by, what's the derivative? So 2 times 7/3, right? Okay. So let's calculate that real quick, okay? 7 over 3 minus, what's 7/3 squared? 49 over 9 minus, I'll write 5 in terms of ninths, so 45 over 9, right? Divided by 14/3. And we'll pick up there when we get back. And by the way, you have a very, very short assignment tonight. Okay, we're trying to come up with a rational number to approximate the square root of 5. So we've got 7/3 now. Minus, the top simplifies to 4/9 over 14/3. What do I do with that? Multiply by 3 over 14. So I have 7/3 minus, see, the 4 over 14 is 2 over 7. 3 over 9 is 1 over 3. So 2 over 21. Common denominator is 21. So I've got 49 over 21 minus 2 over 21 is 47 over 21. So you notice my three guesses were 3, 7/3, and 47 over 21. Now, I know that seemed to take us a little while, but the fact is once you get good at it and you practice it, Newton's method works out pretty well. You try 47 divided by 21, and then you take that and you square it, and is that close to 5? Well, that's pretty ridiculously close to 5, isn't it? Now, it says to come up with it to 4 decimal places. Can I show you a quicker way to do it? You're going to do it like this on your assignment for one problem. Just one problem. Got that? But for the rest of your assignment, you could go like this. Y equals. We take x, and then we minus. On the top, we put our function, right? Which is x squared minus 5. On the bottom, we put our derivative, which was 2x. Make sure you put the bottom in parentheses. Biggest mistake people make. Then, as you have this, you could go to your table. What did we make as our first guess? 3. We get 7/3. What is our next guess? 2.33. 3. What's my next guess? Still was a change, right? So you continue until you don't have a change. So 2.2361 is accurate to 4 decimal places. 2.2361 squared. Boom. There's Newton's method. Let's try one together on the other side. We are not going to finish all of these notes. We're just going to do these 2 problems. They're going to be nice and easy. If you remember, Newton's method says that the next guess, x sub n plus 1, the next guess, is equal to your initial guess minus f of x sub n divided by f prime of x sub n. Doesn't matter whether we use sub 0 or sub 1. The idea is that the new guess is 1 more than the old guess. So what we need is we need a function. If I want to evaluate the square root of 7, what's my function? I also need a derivative. (2x). And what is my initial guess? What would you like to guess for square root of 7? Okay. It actually doesn't matter. You're gonna eventually get there anyway. So you want to do 2.5, that's fine. It'll take a while, but with 2 billion, you'll eventually get to where you want to be. Okay. So 2.5. So what I do is I go to my calculator, I type in Newton's method, which is x minus x squared minus 7 divided by 2x. Remember to put the denominator and the numerator both in parentheses. I go into my table. I have 2.5. My next guess is 2.65. So 2.5, 2.65, 2.6458, and 2.6458. So looks like that's accurate to 4 decimal places. If you want to check it, 2.6458, and we square it, and you get 7. So can you see how for Newton this was a much more effective method? What I would like you to do on your own is letter B.